Dr. Shitala Prasad sir, Assistant Professor of IIT Goa, and Dr. Klein George, Associate Professor of IIT Goa, who will be guiding us on AI-based aerial vision for drones. I request you, sir, kindly come on the stage and take over.
Going to talk about the AIs and other applications which we can use based on our drones and other things. So, so basically, this is what we are doing right now. We are more into image vision processings, object detections, text detections, classifications, segmentations, detecting our biometricals and biomedical things. We are also working on the multi-view object recognitions kind of stuffs. We are more into like HCI based things or BCI things. So and also we are like open to collaborate. Right. So in case if somebody is interested in PhDs or internships or some kind of collaborations, they can look for us. So basically, whenever we see something, so like the drone he has shown, they see something. What we should do after that? So that's what we are talking about here. So there is a computer vision kind of stuffs already. Many of you might be aware of. Many of you might not be aware of. But this is something like whatever we see, we can infer something from those things. So say, for example, if this image is there in front of you, this image can see what? What is there in this, whether there is a house, plant, tree, car and all. We can narrate them. We can also estimate the number of cars. We can also estimate the farthest object we can have. So these things can be used for us to process further and do some kind of analysis and all. So for that, we are trying to develop some kind of AIs. AIs can be, in nutshells, you can just summarize like this: engineering, making intelligent machines to be programmed. Or how we are doing that? We are trying to introduce the ability to learn without explicitly programming them. So that's what machine learning, my Dr. Clint will talk about. And mostly I'm doing with deep learning things where neurons are going to be played major role. So in case if I ask you like this is an image in front of you, what majority of the people will be answering is you are able to see a man, you are able to see a man with a headphone, he's walking in a scene because this is very easy for us because we are over millions of years we are trying to see these things. Our brain is being tuned for these kind of things. So our brain is mostly or easy to recognize any object in a three-dimensional world, right? But this is not the word things which our real world, or sorry, our digital world sees. Our digital world sees objects in such a fashions. So there are like more than 3 dimensions. So we are having like multiple dimensions. We call it as an n dimensions. That n can be even millions or even can be a billion dimensions, right? So our task is to map this 3 dimensions, what we see, to a n dimension, and what n dimensions they see to a 3-dimensional recognition. So when a computer they see some object, how they see is your right side, and what we have to correlate it, we have to correlate it based on our 3-dimensional objects. So just for a quick recap, I can show you this image. So is it possible for us to tell some species names over there on the screen? Can you correlate it with our 3D objects? Pardon? Dog, fox, wolf. So same object. I think second row, second row, second column, everybody is saying dog, fox, wolf. Most of you are getting confused, right? It's very hard for us to correlate those n number of features to a 3-dimensional features which we know, right? So how, if we are confused, then how we are going to make our computer to be run or trained? So we have to have some kind of mechanism, some kind of mathematics, some kind of models which is going to tell that whenever we see this kind of patterns, they are basically a correlations to a fox, dog, or any other species. So that's what we are trying to do over here. So we'll come up with some kind of use cases also. It might be interesting for you guys. I'll just skip some literature so that it will be a little bit more easy. This image is to show you that what biological neural network BNN is and what artificial neural network ANN is. So the top one is your BNN, biological neural network, and the bottom one is basically your ANN, where you are able to see a replica of a biological neural network in a mathematical format. We are going to represent this cell neuron cell body as a function, some summation functions. And based on that, we are going to process them all. So if you connect this neurons one after the other, it will be forming your brain sequence, brain neurons or brain things. So similarly, if you connect this lower one with a set of neurons, it will be your ANN network. We call it as a network. So this is what it is going to look like. So here you can see you have a brain. Sorry, you have, it's not working on that screen, I guess. So you can see that there is a eye. Eye is taking some kind of light informations, and then light is being passed from one neuron to the other neuron to the other neuron, and at the end, following this path, at the end, it's going to tell you whether that particular light is related to what kind of objects, right? So that can be related to one's face, that can be related to one's object like a cup or something. So this is what a neural going to be processed. Signal is going to be processed by several neurons. Following the same pattern, we have come up with a deep learning pattern where you have input image and then set of neurons of arrays of neurons. These neurons are going to process those input images in same way in like our brain does, and then try to abstract a abstract value. So this cat is now represented as like this. In an abstract value, and then they try to recognize that, okay, this particular object is a cat, because we do not need exact text pixel by pixel information to recognize an object, right? So that's what we are doing over here. This is a mathematical thing, so I'll just skip it. And of course, computer vision, vision is not a new thing for us. Millions of years we were working with the pinhole cameras, and even today in our physics, we are doing this kind of pinhole camera experiments. There can be several applications we can use. I'll just quickly tell about the first applications. There was a case in forensics. They need to identify a face, but the face was completely changed from first to the second. But at that time, our computer vision technique, biometrics, they tried to recognize the person's iris thing. And based on that, they were able to recognize. Otherwise, the pixel informations, face recognition algorithm, they all failed. They say that these are the two different entities. But when they talked about the iris things, they said that, okay, they are the same entity, same person. And we can, of course, use for several other applications. I'll just skip them all. What I'm interested in, or mostly we are here to talk about, is our drone things. Right, so drones can be used in all of these things, wherever you feel like. Mostly we are working on agriculture, surveying, and patrolling kind of things. They started in 1849 when Austria dropped 200 bombs using an air balloon. So from there, the concepts of unmanned vehicles came. And since in our previous talk, several types of drones were discussed, basically we can categorize drones based on their wings, their size, their payload capacity, and also range, so power source, and the motor types they are going to use in their drones. So below one is based on their wings. There are several others categories, but I think we need not to go in the details, but I'll just put it on your screen. So in case if you are interested, you can have a look. So there are several other types, categories of drones based on what you can categorize them. So if I talk about anatomy of these drones, they can be broadly categorized into this way. You have a propeller, you have a motor, you have a frame. That frame can be a 3D printed, because we are printing it 3D because we are customizing it depending upon our use cases. You can have a place to battery and a camera. You can have a flight controller. You also have a power distributor, because we need to distribute the powers to each and every motors, each and every sensors continuously. Otherwise, there is no point in having drones. So this anatomy can be used for any types of the drones. Only the thing is the drone size and weights or the sensors will be changing. So since we are talking about drone vision, I'll be more focusing on the vision part kind of things, but of course we can talk about the other things off the record. So here there is kind of like helicopter type of drones, tricopters, quadcopters. Most commonly we use tricopters. The one which was shown previously was a tricopter, quadcopter, not tricopter, sorry, by mistake. quadcopter, so they will be having 4 propellers. So it's easy for us to balance. So if we have 4 propellers, it's easier for us to balance. Otherwise, it will be difficult to control them all. Right. So whenever we have these things, we have some kind of sensors. Since I'm talking about vision things, so we have a studio vision sensors, we have a laser sensors, we have a monochromatic sensors for used for different kind of tasks like agriculture and other things. So we can use all of those. And these sensors has some kind of good things, which is something like this. They can be used for optical cameras. They can use for infrared cameras, thermal cameras. Say, for example, we use these cameras for at the time of COVID situation, we wanted to monitor people with a temperature or not. So we use this kind of cameras to monitor the temperature, whether that person has a high fever or a low fever, and then do some kind of controlling for that. Right. We can use multispectral cameras for our vegetation indexings and other kind of tasks. LiDAR for our 3D mapping or reconstruction areas can be used. Other than that, also we have some set of rules on what basis we have to choose our cameras. They can be all these 4, not only these 4, but can be resolution, field of view, weights, and the cost. If you have a lot of money, go for it. I think any device you can buy it, not a problem. But if you have limited number of amount of money, you have to look for all these kind of feasibilities. So there is one thing which is a payload called concept. So whenever we add some device to the network, these device has to be whenever they will be added onto the drone will be weighted. So in that case, the drone propeller has to be good enough. The motor has to be good enough to lift it up. The battery has to be there. So and so and so. So for that, we have some kind of mathematical formulas to be calculated. That okay, this drone is with this much battery, then can it lift it or not? So we have some set of formulas for that. We can do it. So in nutshell, what we can say is we have some data, whatever we see from the drone, and then we try to do some kind of black box kind of stuffs and pass those images to that black box and get some kind of predictor output. We'll talk about those outputs in detail, but I'll stop over here and ask my Clint George to continue with the machine learning part, and then I'll go over to the case studies kind of stuff. Yeah.
Okay, good afternoon, everyone. Okay, I'm Dr. Clint George. I'm an associate professor at IIT Goa. Yeah, thank you, Dr. Sridhala, for the kind introduction. And so you have seen, many applications of drones, and so it can be used in many places. Okay, so what I'm interested in, or what I'm currently doing. So we work on the algorithms. Okay, so the idea is that so when you get some data collected using drones or some other devices, so how can you use computers to understand the data? Okay, so I will just step back a little bit. It may be a little bit technical, but I don't spend much time on that. Okay, so you can ask me questions anytime. Okay, so what I will do is I just give you a quick introduction of machine learning algorithms. So what are the different types of algorithms that can be used to understand data? So before I start, I will just show you a couple of images taken by drones. Okay, so here we have an image. So can you identify what are the objects that is shown here? So these are birds. Okay, and the photos are taken from the top. Okay. So the problem that we are interested in is that, I hope you can see the pointer. Nope. Okay. Okay. So I'm interested in the bounding boxes. Okay. So when you have an image like this, so when you run a drone, so you have a video, so you can split that into images. Okay. So from that images, we are interested in identifying the locations where these birds are. Okay, so that is one aspect. The other aspect is we may be interested in which bird it is. So for example, here we have different colors that represent different types of birds. Okay, so one may be interested in doing a survey of birds with the help of drones. That may not be a practical aspect because drones also make some noise and it may fly. Okay, but these are nesting zones, so probably they will stay because they wanted to protect the area. Okay, so this is another figure. Okay, so here there are no moving object. Okay, we are interested in identifying the species. Okay, species of the trees. So you can see there are some palm trees, then there are some trees which are big, and you see some trees which are bushes. Okay, so we can use these drones which can be flown in an area, and we can identify the density of a particular tree species. So that is another application. Okay, but to do all these, getting data is okay. I mean, we can have camera and somebody has to just run the drone and get the data. Okay, but in the end, we cannot actually go through each and every frame and do this. Okay, so we have to use the computers, or we have to train the computer to understand these locations or bounding boxes, then classify them. Okay, so I will just quickly explain. I mentioned data. So that is like the data that you get from a drone. So here I have shown a data that I mean, this is the way the computer actually see. When you look at an image or a measurement that is taken by a device. Okay, so here I used a data set that is easily available, that is used for learning classification and similar algorithms. It's called iris data. So this is just to understand what is a data that the computer read. Okay, so you can see you have a table, and the columns represent the features of the data, because you see this when you are trying to understand the algorithms that you can use for classification and other things. Okay, and the rows are the measurements. So the idea here is that we are interested in classifying these iris flowers. So there are like 3 types of iris flowers, and we would like to classify them based on the features. So those are the columns. So here all are just real valued features. Okay, so we may not be able to quickly understand unless you go through each and every row. Then you make some summary statistics. Then only you can get some idea whether a particular object is, or one row is coming from one species or the other. Okay, but if you can train a machine learning model, then that will be able to so whenever you get a new measurement, it will be able to predict whether it is from one species. So there are like 3 species in this case. Okay, so I'm just trying to give you the perspective. Okay, so the features are the things that you see. So in the case of images, so the features are what? So what is an image? So what is an image? Image consists of it has some dimension, but it is basically a representation of many pixels. Okay, and if you look at an RGB image, so it has 3 channels. Okay, red, green, and blue. Okay, so all these mean something, and if you have many sensors attached to the drone, then it may add more value to that scene. Okay, and hyperspectral data, you have different wavelengths. Okay, the data that you collect from the scene. Okay, so let's suppose you have data collected from these devices. The first thing typically, I mean, you have to understand the data, right? Then only you can develop something. The first thing typically what people do is they do some kind of visualization. So this is just a visualization that we all know, because you probably learned this in a high school also. So you just make a scatter plot of the features. So here, if you look at it, it's a graph on a plane, and on the x-axis you have the sepal length. So that is one of the feature, and on the y-axis we have the petal length, and different colors represent different types of the flowers. Okay, so you can think in a similar way when you are looking at the images that is taken by the drones. Okay, and I just put some notations. Don't worry about that, because when you build some algorithms, you need to represent your data in some mathematical form. So that is the idea. Okay, so by looking at this figure, what you can understand from here. So you see that so that red class, so that is I think that is Setosa, that is there at the top, and that is quite different from the other 2 classes. Okay, so what I am trying to say is that for this type of data, by just putting it in a screen, in a scatter plot, you may be able to understand, something about that data, okay. But think about the data that you collect from the drones, so which may be of some high resolution, okay, and you consider each and every pixel as one feature, okay, then you may not be able to put that in a screen because there are several dimensions of data, okay. So you need the help of computers, okay. So that is what I wanted to stress out at this point, okay. So what I will do now, I just quickly go through some some terminologies that you may see when you are looking at the algorithms that you can apply on image data. So the first one is called the supervised learning or classification problems. So I think most of you might have heard this somewhere. You use AI algorithms for classifying something, maybe classifying different types of chairs or different types of fruits or something like that, okay. So the idea is explained in this figure. So you have two features, x1 and x2, okay, and different colors or different markers represent different classes, and we may be interested in finding out one line like this, okay, and that line will tell you whether you are coming from one class or the other class, okay. So here this the problem is represented in terms of identifying that line, okay. There are some algorithms that does that, okay. Here it is an easy thing because it can be visualized in a plane, okay. And there is another set of problems, so where we are not actually interested in the class, okay. We may be interested in finding that line, so that from the data you can tell there is some kind of a pattern of the data. So these are called regression problems. So the previous one was classification problems. Then there is another set of problems where there is something I didn't mention in the last two slides. So here in the previous two slides, we assume that every measurement that we make is labeled to something. So initially I mentioned there is a scene based on some bounding boxes, and each of these bounding boxes are assigned to some classes, okay. So these data is labeled, so that is one of the hardest step that you need to do when you are making an AI system, okay. So regression and classification, we assume that this data is labeled, but here we assume that data is not labeled. For example, you have images of several areas, okay, and you would like to group these images into something, okay. So for example, you might have flown this drones over near some waterlogged areas, for example, and other places there are a lot of buildings, and other places there are some forests, okay. So you may be interested in grouping these images into forests, then water areas, and maybe some city area or something, okay. So these are called clustering algorithms, and all the machine learning algorithms that we talk about can be classified into any of these categories, okay. So that is the idea. So now what I will do, I just quickly I also talk about some of the things that Seedhala touched upon, then I think I will leave the stage to Seedhala to continue, okay. So this is a little bit of history, this perceptrons, or these are like the grandfather of deep learning or something, okay. So the idea is this. So you have some input, so this X are the inputs, so you can assume these are the pixels that is taken by the drones, and you apply a function that is a weighted sum of the pixels, and you put a hard delimiter like this, so that is shown at the bottom. The idea is that based on the the value that you get, +1 or -1, you classify the objects into one class or the other, okay. And these are called perceptrons. It was developed, you can see it's 1959. It is one of the oldest I would say neural network models, okay, and it is derived based on the idea of the biological neuron, okay. And the question here is that so we have the data, we have the label, and the idea is that so how can you learn the weights? So the weights, so once you learn the weights, okay, you can discard the data. So you use that network for future predictions and other things. So that is the idea. Okay, I am just quickly going over these things. Usually when we teach this, we spend some time in all these. Okay, yeah. So the idea is that this is something we have already mentioned. So we would like to find out a separating plane that can separate different types of classes. Okay. So then so here I have shown a representative figure of a feed forward neural network. So that is like a deep neural network. So which has, in deep neural network you have several such layers. So you have inputs, so which are represented by the circles. Then you have some hidden layers. So here we have only one hidden layer, and so this these nodes are connected by edges. Okay, and in the end you have an output layer, and this output is something you learn, you get from the network based on something that you have learned as part of the learning process. Okay, and how do you learn the weights? So that is based on the deviation. So if you are looking at classification problems, you may be interested in getting a classifier that can classify all the data points well. So basically we would like to minimize the misclassification error. Okay, so that is the idea behind learning these deep learning models. So that is described here. So you have a network, you pass all the inputs. So you can assume you are passing all the images to this network. In the end you get an output, that is y hat, and you compare that with y. So that is your actual label. So that can be like one type of a bed or the other type of a bed. Okay. So when this network is not classifying well, so you have to tweak this network so that you can get a better network after several iterations. So that is the idea of learning of a neural network. Okay. So now I just quickly go through. I stop all the theory. Now you can look at the the interesting applications. Okay, of some of our students working nowadays. Okay. So thanks to Anish, Prahlad and Vishwajit. So we have a booth outside. So you can also visit the booth and also talk to the students to know more about these projects. Okay. So one is the one that I have shown initially, how to identify the species. So these are the data that we use. You can see there are like 4 different types of trees. Okay, the data is collected with the help of some drones, and we have bounding boxes and the labels. So this is like the training data, because we are building a classifier or object detection model. And this is some details about the data description. The only thing that is interesting is the left top graph. So that gives some distribution of the classes, different types of trees in the data. So we use something called a customized deep learning model. It is called YOLO V8. So that is one of the state-of-the-art models for object detection. And here you can see the model's prediction on the data that we give for testing. Okay. So these black boxes represent the labels, the true labels, and these orange boxes or yellow boxes represent the predictions of the deep learning model, and also the classes that is identified by the deep learning model. So this is something reasonably well. I mean, we also have some statistics that we are not showing here, because that's not very much interesting at this point. Then we also use drone images to detect different types of animals. So I will show you. I mean, this is the training data that we use to train our deep neural network, and you can see these boxes represent different types of animals. I know it's not very clear from the back, but the data looks something like this. You also see that different types of backgrounds are also there. So this is one typical application, of drones in the agricultural domain, or you want to survey a particular area. For example, you would like to see the wildlife, distribution in a particular area. Okay. So these are the results from from our models developed by our students, and you can see it's actually doing a good job. There are some misclassifications, but it's okay compared to the data that we have. and so we have bounding boxes and the corresponding labels. Okay. So we also do other interesting projects not related to drones. So one is that I and Seedala guide one student. So he also presenting a poster here. So we are interested in doing segmentation of cells. Okay. So the idea is that can you identify the boundaries of the cells so that we can count. So this is similar to the problem of identifying species in a location or something. I will just quickly show you some results. So these are some type of cancer cells. Okay. And left one is the data, and this one is the mask or the labels, and the right ones are the results coming from our models. Okay. So you can see that it's kind of doing well with compared to the true labels. Okay. I just stop here. Okay, I just leave the stage to Seedala to continue.
So thank you, Dr. Clint. So he talked about some of the use cases where we are using drones as well as where we are using AI things. So I'll continue further. This is how the object actually sees, or the deep learning they actually works whenever they see an image. They try to extract the features based on vertical edges and horizontal things. I'll just skip it faster so that I can move towards the application point things as we are running short of time. So here the basic things which I needed to highlight it is like whenever an object is being detected, we try some kind of mathematical operations. There are some neurons which is useful neurons. There are some neurons which is not so useful. So we try to do some kind of activation functions over there and try to extract only those things which is really useful to us. So this white pixels on the extreme right, they are basically the useful things, and the shadow gray ones are now removed compared to this one. Here you can see the gray along with the white things also. So those gray and the black ones are of no use. We should remove those neurons. That's what we are trying to show over here. So this is what we are trying to learn over the time period. And now there is a quick questions for you. I mean, maybe you can tell me out. So seeing this image, what we can see is there is a beach scene, right? Somewhere in the Goa, maybe. I don't sure. And what we can see, there are some objects. There is a restaurant. There is a light open. So that means 100% we are sure. Since light is on, it's an evening time. And it's a very aesthetic picture. So maybe possible we can go with our partner and then spend some time over there. So other than the objects, we are also trying to correlate with the inference from those objects, right? We can also correlate with that. So yeah, so this is another example where usually dogs do not behave like this, do not go on the terrace and then see something. So basically this is not a dog, it's basically a cat image. Here now it is a little bit clear for you. So other than seeing, it's same like whatever we see is not always the true. Similarly, the network also what they see is not true. For a network, in the first image you can see it's like quite close to the dog. Like almost 90% will say that this is a dog only. But if I show you the second image, then now you're saying like, okay, your brain has been tweaked. Now you're getting another impulse, another biased phenomena that this is a cat image. So that's how network also gets confused, because it's very easy for our BNN to get confused, right? So there are some atmospheric conditions also involved while processing the data, like motion blurriness, because the drone is moving. So the objects which is being captured or recorded, they will be in blurry motion. So we have to have an AI thing so that they can remove it out. We need to do some kind of stabilizations. Atmospheric distortions is also involved because there will be a white background noise. We have to process those things. We also need to process the shadow images, because while capturing some image, there will be a shadow. You can see that bike shadow is there. Also, sometimes we need to calibrate the cameras because it's taking from the distance thing. So you are able to recognize a person from the frontal view, but is it possible that you can recognize the same person from the top view where you are only seeing the head point? So almost like 99% objects are going to have from the top view, right? Same features. So we have to process on that. And then we have to do a data processing kind of things, because whenever we have an aerial view images, those images are very small, very tiny, and completely from a different scenario. Like we are not used to see any person from top to bottom, right? We are used to see frontal layer. So we have to do some kind of processings. And of course, whenever we do this kind of processings, we have some cost involved. So we have to tackle all those things. So this video might be interesting for you, which will tell you the exact details. Okay, anyway, audio is not coming, but it's okay. Here you can see that the objects are getting blurry or getting too much exposed to the light and other things. So that's why the recognizing an object is a little bit difficult. Here the objects are quite big enough, like a car and other things. But when we talk about the vegetations, the flower, fauna, in that case, those will be like very, very tiny to us. So whenever we use image processing algorithms or deep learning algorithms on that, top of it, it's very hard for us to recognize them all. Right, and also shadow is going to be a big picture for here, because here you can see there is some cattle there, but the cattle image is very small compared to their shadow image, right? So deep learning is very easy to get confused that which one is correct. The shadow one is the actual object, or the cattle is an actual object. And the first image you can see there, it's too much of exposure is there. So the objects will be like not very clear. We can't even see the aeroplane's cover. Right. So to tackle with those things, we can use these kind of things. We can use a kind of high quality camera. We can use stabilizers. We can use gimbals. We can use fast shutter speeds and all. So get rid of those kind of things. Right. Here there is one question for you. Why I'm telling you that vision is very important or resolution is very important, because of these things. Like in case if I show you this image in front of you, is it able for you to recognize what this object is? If it is, then just can you name them? What object is there in front of you? Cuff? Cuff? Any other? Something like a teeth? No? So I think only one person has answered, so I'll assume that only out of 100% BNN, only one BNN is working very well. So if I try to increase the resolutions, now your confidence rate is getting higher. Now you can, out of this 100%, I mean 100 persons, more than 90% might be assuming that what this object is. Little bit more high confidence. Now more high confidence, right? This is what we are going to teach our neural network also. Whenever we give better resolution images, better resolution input, the network will be more confident. Now the question is whether this object is real or fake. Real, fake? Fake? 100% all of you are agreeing with this fake? Koi real hai? And then now the question is, I'm not showing you the fake information or real information together on the same screen. Then how can you categorize them? On what basis we are going to say that this particular object is a fake one? It's not there. I mean, it's not like it's not a 3D object there, right? Because our brain is more used to have a 3D object informations more correctly. So now here we are going to tell you another level of advancement, like our brain does it very casually. Unknowingly, they said like it's a fake thing. That's correct for sure. But how? On what parameter you have done it? So that's what now we are doing with an explainable AI. So we are also trying to explore whatever the predictions are coming from the AI-based model, why and when they said it, right? So this is fake for sure. You can see the carpet area. You can also see the emotions. This emotion is very steady. So that also can be one of the thing. Maybe you can come up with your own parameters, but that's like learning things. Every neuron, every biological neuron has their own way of learning things, because in a class there are 100 students. There is one teacher teaching the same information, but everybody is getting different marks. Same thing like that, right? So these are the things which we are doing. I'll just skip it. This is what we are doing it. And in the red colors, in the red colors, we are doing. I mean, at IIT Goa, I'm working on these things. So I'm mostly working on the object detection, tracking, agriculture, crop monitoring, underwater imaging, wildlife conservations. We are also working on the precision agriculture, human detections and recognitions, traffic monitoring. We are working on using drones and all things also, including. Right. So we can look for this. Types of UAVs being used for They can be used for construction areas, they can use for farming, they can use for as sports analysis, they can use for law and order maintenance, they can also be used for patrolling kind of things. 3D printings can be used, package delivery things. Managing the crowds can be used. We are also working on that management of crowds. And 3D constructions can be used. There can be also unmanned vehicle for underwater also. We are working on ROVs too. And there can be nano drones which can go inside your blood and then can do their operation and then can dissolve it also. So these are things, different types of UAVs not via, but there are existing. So most of the times these drones which was shown before, they're like from some companies. They don't allow you to get the streams of the cameras so frequently. So we design our own drones, we design our own cameras, we design our own settings so that we can access those each and every components on our system and then program it based on our requirements. So we try to design our own drones which is light enough on, we can take it on our palm and then that can fly anywhere in any corner of your room and then record those things. These are the components which is required for to design one drone. So it's like roughly 2,000 rupees you can design one drone, including your cameras things. And then that can be live projected to your mobile or to your laptop. And then you can use some AI tools, some Python algorithms to process those things. And on the fly, you can control your drone without it, disturbing it. Right. So these are the things which I was just showing you. This is the close-up of a drone. You can check them all. These small components, everything is like the frames, including the frames, motherboard, and everything has been designed by us and printed. So you can also see all those things. It's very easy for you to design it. If you want to understand more things, there's a booth outside. We can showcase how to design it also. And then we try to test it. But at the time of testing, there was some issue that before it take off, it slides because of this barometer sensors and all problem, right? So we tried to test it on our ground, in a ground also, but then we thought like we found like this drone is like actually bouncing more and more. So it's like something like a rubber ball. We tried to program it. So now the drone is like bouncing each and every time, right? So for that we have to calibrate better way that the barometer will give you a better performance. So this is where your air pressure is going to act. So even if there is a slight change in your air pressure, the barometer will give you a big change. And if you do not calibrate properly, the drone cannot stable, right? So for that we have to have either high-end sensors or a very good program. So it's bouncing like this. And then this kind of drones can be used for 3D monitoring. So any object can be recognized from any of the corners. And since we are talking about supervised and unsupervised things, if my model is able to recognize a person from frontal view, is how well it is going to recognize a person from the back view or top view. So that is a kind of like unsupervised or unseen data. So in that case, our model is going to work out better in that case. And also, Dr. Clint was talking about labeling and data. So labelers are very costly. Since, say, for example, in this case, I have 3 labelers, labeler 1, labeler 2, labeler 3 is there, right? So all the task was to label the text instances. So whenever we try to label the text instances, different labelers have different mindsets, so they label data differently. One has labeled very well, other one has labeled it not that well, but okay. They missed the small text instances, but they labeled the other ones. And the third labeler is even lazier. He created a bigger bounding box for all the text instances, right? So if you're passing such kind of garbage data or noisy data into the network will learn something else instead of learning the exact scenes what he has to learn. Same thing is being tested in that case. So whenever we use that kind of data, our text detector is going to detect something. So our text detector is detecting a character I or 1 in first image and the second image or letter M. But if you see the bigger picture of it, it's not even a text instance. It's something like a noise data for us. So in that case, our text detector is getting failed. Similarly, here also text detector is getting failed. So what we try to do is we try to do a hierarchical approach, like what we do it. Like a person coming from a distance, we are able to make sure that that person is my friend. But the time it coming close and close and close, we are getting more features, and then our confidence is getting better and better. So that's what concept we have adopted over here also. and then we made sure that our detector is not going to predict a false alarm. So for that, we have identified a positive and a negative reason within an image where the text can be there. So text cannot be there in the sky, but somehow because of the tree, because of the cloud, the pattern has been something like a text. So in that case, our text detector will fail. So, but if I know that this is the sky, we should make sure that the text detector is working very well in that case. So if we know our positive reason, we can easily detect it without any failing mistakes. So we have trained our object detector and then followed by a text detector and then club them all together to come up with the text and the background things. So that was being used for petrol monitoring and other things. So here you can see it has been trained on, it has been tested on random data where the network was not being trained. It's completely unseen data. We used it for our petrol crime scene recognitions also, where the cars was being identified and the numbers and the names were written on the cars that was being identified, and then based on that we formed some kind of stories, and then the person was being identified. To make sure that whether my network is learning very good or not, you can recognize this last text. With 95% confidence, the bus number, the bus name. And whenever we introduce a positive class, because text can be there on a car plate is on the car. If I can identify a car, that car is basically a positive thing for me. So the confidence rate is increasing from 95 to 97. If I introduce a negative instance, the confidence is getting lower and lower, and now it is 86%. So almost like 10% dropped. Same thing was being used for text detections also, because usually it's a record that whenever you have a tattoo, likely the crime rate is a little bit high. So I'll just skip them all. I'll go to the drone application mode. So here you can see the drone is able to detect. This is the output of a DJI drone. So we are trying to come up with a live scenario where the DJI drone is able to detect pedestrians and also able to detect the vehicles, and then try to create a kind of map where the more cluster is there, and then based on that we can do some kind of operations. So this is almost like real time. We try to deploy it, and then we use drone to track it. Like there can be multiple drones, and then if one drone has identified some suspected person, can it be possible that the other drone can also track it, like if it is away from the first drone's viewpoint? So that can be also used. So drone can be used for tracking kind of things. A person can be identified, and then drone can be asked to track that particular person, right? So this kind of map we can create based on our camera positioning or drone centers stations where the drone is sitting idle. Then the drones can be getting a signal that, okay, this is the suspected person, you just track it out. So it will go behind that. And we are also using it for crowd monitoring. We can also use it for crowd monitoring where there is too many crowds. We can get a law and order maintenance kind of things for that. So our IIT Goa has come up with a kind of like a voter dose. Last elections we proposed these things. So this was being proposed by Professor Sharad Sena and their team. So they used it for monitoring the voters. And then we used it for agriculture also. We have some pipelines over here, you can see. We use it to monitor whether the crops are actually damaged or not. If it is damaged, then damaged up to what level. Whether it is repairable or not repairable, whether it is going to be cured or not. So we come up with these kind of metrics. We also used a drone to see whether that particular spraying is being done in their farm or not. Because the farms are usually irregular shapes. So can it be possible for image processing algorithms to work out on the drone, and then over the flight can monitor that, okay, this is my field, this is not my field. So they can identify the borders, and based on that identification, they can spray some kind of pesticides or some fertilizers. Again, the same thing, I think Clint has already mentioned these things, so we'll just skip it out. Okay, so whenever we work on drone things, we need to work out on the small object detections, because the drone can be at 10-meter height or 100-meter heights, right? Or even 400-meter height. So in that case, the objects will be changing their size. So we have to come up with an algorithm where these small objects can be detected even with a different varying height. So we come up with an algorithm which is 100 frames per second. So on the real time, better than the real time we are working. So it can be easily deployed on our drone, and then can detect this. This is more like a real time things. So to make it more real time, we are using this kind of approach. The real model is being converted into ONX format or TensorLite format, and then burned on the edge devices, and then actually is being used in our practical life, right? So this is, we usually try to conduct boot camps like once in 2 weeks, 2 months or 3 months. So if you are aware, near around, you can always come to our Center for Drones Applications and look for these boot camps. We'll be talking more about these experiments, these designs and all algorithms in more details. So you can go for that. And for now, you can also visit our boot camp here in next year. So that can give you more insights in this story. Yeah. So that's it.